Okay, on the next day we talk about the confidence interval on the mean, but now we will continue about the standard deviation. Or sometimes we talk about the variance, that's not variance. It's sigma squared is variance, sigma is standard deviation. Usually we represent by S. S is the standard deviation of sample, or S squared is the variance of sample. But for the variance or standard deviation, we use the sign squared here. For previously, we talked about the C distribution or normal distribution and T distribution for the mean. But in the case of variance or standard deviation, we use the sign square statistic. As I introduced you in the distribution already. The test statistic that we use for sign square test, we represent by this sign square equal to n minus 1 s squared divided by sigma squared. Right. S is the sample value, right? And sigma is the standard value for this. Maybe we talk about the operation and we do the last. Finally, we check the confidence interval, right? The percent confidence interval 101 minus alpha, 45%. It should be 95 CI, for example. Alpha equal to 0.05% CI, that means 95% for that case. We can calculate the minimum and maximum or lower or upper bar for the variance. Sigma squared is variance for that case. We calculate based on statistic test is the size square test. Size square test also depends on the degree of freedom n-1, right? n-1. This is for two sides. If you would like to calculate lower bar, upper bar, if you consider the one side, it may be upper bar or lower bar. For that case, for two sides, we use sine square at alpha divided by 2, right? For two sides. If you consider only one side, upper bar only or lower bar only, we use sine square at alpha, right? Sine square at alpha. As I talked to you already, normally in engineering or science, we use 95% confidence or 0.05 significant level. That's right, significant level. That means alpha equal to 0.65. Like for this example, we consider the automatic filling machine. We used to fill some liquid detergent in the bottle. I think you know the detergent. You can be detergent, you know the detergent. It's some chemical for cleaning. Right? Cleaning equipment, cleaning human body also, right? From soap, from like the laundry, something like a lot of the chemical for detergent is for cleaning, right? Cleaning for that case. For this case, we random sampling 20 bottles from the population. That's right. 20 bottles from the population, and then we determine the variance of sample. The value of sample is 0.0153 square, right? This is the free square. If the variance of the volume is too large, right? And unacceptable proportion of bottle will be under or overfilled. Right? We will assume that the field volume is approximately normal distribution, and we check by the 95% confidence interval. Right? Confidence interval, that means we would like to determine the maximum, right, or the overfill should be the variance. The variance for that is based on 95% confidence interval. For this case, we cannot check two sides. We only check the maximum that's possible. The maximum that's possible because the error based on we fill in the bottom. That way, the maximum that will be overfilled. Okay, for this case, we use the upper confidence. We use this case. We will consider this case. We consider this case. Okay, for we would like to determine the sigma square of variance is greater than or equal to n-1 variance of sample, and then divided by the statistic of size square. Size square at alpha. If for this case we use sign square at 1 minus alpha. Alpha 0.05, 1 minus alpha is 0.9. Degree of freedom is 1 minus n minus 1 is 90. Right, you open from the side square table or you use the Excel. Right? I show you last week for the Excel to make the side square table. And then you get the maximum is sine square or sigma square should be 0.0287. Or sigma is less than 0.7. This is based on 95%. 95%. If you calculate the standard deviation of your sample is less than or equal to 0.1, okay, we accept this error. If it is elevated than this, okay, there are some problems you have to check the process. For QC, when you check the product, you have to set up what is the unacceptable or acceptable region that you collect that you would like to get that for this. And also I show you how to calculate from Excel to use the size square like CSI inverse. You know alpha minus 1 minus alpha is 1. You know the field of freedom. You can use the size square. And the last one for proportion. The last one for proportion, if you check the proportion, this is very important if you would like to check the defect in your product. If you produce some computer, you produce some code, you produce some another piece of product, it's about 1 million pieces per week, per day, and then you would like to check what is the defect. And usually we have defect, but you have to set up what is the error that you can accept for that case. But it can usually be measured based on proportion, the size proportion. Number of defects per number of samples. It's like what is the percent of defects? Usually we use the normal distribution or C-test. That's why we use the C-test, C-distribution for this for that number of the proportion. So usually when you use the proportion, the number that you collect should be a bit is greater than 30. Usually we produce a product is about 10,000, 100,000 pieces. You can select 100 or 200 is a big data or big number. Okay, you can choose the last sample. You can use the C-distribution. This is the statistic test. We use this statistic test. We use this test. Okay. And then you can transform into the confidence interval. This proportion. This is the upper bound of proportion. This is the lower bound of proportion. It's based on two sides. We go to alpha divided by 2 get the same. The same. And then we use the C distribution into normal, normal distribution. And P is the ratio, the sample that you collect from population or number of defects per number of samples. For this. For this case, it have some comment. The procedure is depend on the accuracy of the normal approximation. This is depend on the data that approximate to normal in relation to the binomial. This should be normal for that. If you can check by if we find NP and N1 is greater than 5, okay, this technique can be accurate to apply to your data if you check the N multiplied P, or N multiplied N minus P greater than or equal to 5. Okay, your technique is accurate enough for this. This is for upper and lower. Upper and lower for this. And this is we check the automobile, like automobile engine. Crankshaft wherein we have 85 automobile. And then we 10 of these have a surface limit that is larger than specification. This is a defect. So we check the automobile engine, and also we check the surface of this equipment and check the roughness. And the roughness is greater than the spec or not. We found that 10 samples of this, if the roughness is greater than the specification. And again, spec It's many specs. It's a spec based on your design. It's a spec based on customer. You have to check what is your spec. Usually industry spec is customer. Customer is spec. Okay. What this is the proportion equal to number of defects divided by the number of samples. Defect is X is 10, number of defects is 10. Sample we collect is 85. Defect P is 0.12. And then you apply this formula to calculate the lower bound and upper bound for this. You get like for 95% confidence interval. You know this already. We use it a lot. It's 1.96. It is the rate because we use it a lot. You substitute P, substitute N. You get the proportion is 0.05 to 0.15. That's right. If you collect your data and then you check the defect, if the proportion of defect is in this length, okay, we accept for that thing. This will mean the equality that you check. Because you should check or QC your product and then you check the proportion. That's why you collect your product. For today, you produce about 10,000 pieces. You collect about 100 pieces and check the defect. Okay, if the defect is in the spec, for the spec we accept as the other between 5%, or 95% confidence interval. Okay, if the defect is located between this value, okay, we accept. I think every product that company produces is defect, but not 100%. But if we are some acceptable brand that we accept, if you use the robotic, it may be high to accuracy if you compare to the human for that.